Hi, welcome to the first in a series of CTF walkthroughs. What I have on the screen at the moment is a useful links wiki that I created on a OWASP Belfast group. So here I've put a list of some of the best CTF sites, whether it's live CTFs like CTF Time, VMs you can download like VulnerHub, all kind of wargaming challenges like we're going to be going through at the moment on OverTheWire. So OverTheWire has, it says here, a range of wargames with different topics. So we're going to start with Bandit. It has 27 levels and it's just learning the basics. We'll probably move through these pretty much in order, but I'm going to try and go through. Not all of them are active. But most of them are, so I'm going to try and go through them all and get them up onto this YouTube video. So I'm going to put each of these series I will put in a single video, and in the description box I will link this wiki, the challenges that we're doing on that particular video, and then some links to skip to challenges. So if you're just stuck, for example, on level 20, you can just go and click level 20, it'll skip through and go straight to me solving that challenge. So I'll try and talk through some of the logic as I'm doing some of the challenges, or tell you more about the commands. There are hints on some of these challenges anyway, and you'll see that, I mean, particularly with Bandit, we'll be starting off with some really basic stuff. So if I open up this, I'll just close that down. So it has a suggested order for some of the challenges, not for all of them. We're going to start, as suggested, with Bandit. So you go into Bandit. Just to note, I'm just running Kali Linux here. So you can use pretty much any Linux system for a lot of this, but Kali Linux has a lot of nice tools in it, and it's good for kind of pen testing, hacking, capture flags, whatever you want to call it. So some notes for beginners. I'll let you sit and read through that if there's no point me wasting too much time. So we start on level 0. Level goal is to log into the game using SSH. So we need to connect to this address on port 2220 with the username Bandit0 and the password Bandit0. So pretty simple. We will SSH with the user Bandit0 at the address that they gave us on the port that they gave us. Yes, we'll keep connecting, and then it's going to ask us for the password, which was Bandit0. Okay, so we're in. So that's the first challenge completed, and then we can just move on to the next challenge. It's pretty handy on each of these levels. It'll give you some helpful reading material, some useful commands to look at. So if there were any commands that we weren't too sure about, we hadn't seen before, we could just do SSS-H, see what some of the options are that we can use with that, or we can, if we want to get a lot of information, we can have a look at the manual. Okay, so now we can move on to level 2. So, or level 1, should I say. So we go to the level 1 page, and the password for the next level is stored in a file called readme in the home directory. Use this password to log into Bandit1 on SSH. Use SSH on port, yeah, okay. Okay, so first we need to get the password. So we can see, if we do ls, list the files, we can see the readme is sitting right there, and it suggested some other options like cat, which is basically going to just print that to the command line, and there's our password. So from there we can SSH to Bandit1 at bandit.labs.overthewire.org on port 2220. Oh yeah, there's quite a bit of lag sometimes on these servers, they probably don't have the most bandwidth. So if there are challenges that can be solved offline, you're probably better off just solving them offline than going and submitting a solution. So we do want to just paste in the that, and now we're on Bandit 1. So again, we will go back and have a look at level 2. Okay, so level 2, similar challenge. Next password for the next level is stored in a file called dash in the home directory, suggesting the same sort of commands to solve the challenge. So obviously this is going to be a bit different to the previous one. If we list the files, we can see that we have dash. If I try to cat dash, however, we're not getting a flag. So because of the file name that's been used there, what we actually need to do is add a / at the beginning. There are other ways to do this, but that's a pretty common way. You'll see when you have scripts and stuff as well, that'll be a way to actually run scripts. We'll probably see that later. So we've got the password now for the next level. I've copied the bandit.labs.overthewire.org address and a port number just to speed up SSHing into a new box. So we will do bandit 2 and then I'll paste that in. We'll connect, and I'm going to copy this password. Yes, keep connecting. Here's a new password, and we're into level 3. So let's go back and have a look to see what it's asking for. Okay, so this challenge is asking us to print out the flag from a file called spaces in this file name. So again, not quite as easy as just printing out a standard file based on a file name, but if we go back and have a look, we can see we have the file there. Because we have autocomplete, we can just use tab to actually put that straight out there. So all you really need to know is, in general, you need to put a / before spaces in order to escape the character. But because we have autocomplete, it's pretty easy just to get that there. So we moved from level 2 to level 3, so we're going to SSH with our new password to bandit 3 at, there we go, grab the new password, and there we go. So level 3. Okay, so level 3 to 4. I may get confused sometimes with the level numbers, just based on the fact it started at 0 and it doesn't really show you the level number each time. It's saying it's going from level 3 to level 4. So if I do, you should be able to notice. I mean, if we're working through the same challenges at the same time, you should be able to see whether I'm out of sync with what you're doing. So we have on level 3, we have the password for the next level stored in a hidden file in the in here directory. So if we go back to our terminal, we can see that there is a in here directory, so we can use the cd command or change directory to change in there, and then have a look to see what files we have. We don't actually have anything showing, so we'll try and do another ls command, which is going to give us some more info, and we can see that there is a .hidden file. You can see here in terms of the ownership, we have root, bandit 3. This one is owned by bandit 4, but bandit 3 has access to it, so that's good. So we're going to try and cat that out, and there we go. We've got the next password. So again, the usual process of SSH to bandit 4 at need to copy over the address again, and there we go. Yes, we want to connect, and we paste in the new password. Okay, and then we can go and take a look at level 4. Okay, so level 4 to 5, the password for the next level is stored in the only human readable file in the in here directory. So there's a few methods we could use to determine this. we can see that there are 10 files in the directory, so there's no real indication based on listing the files in terms of file size or type or anything like that. If we were to do check the type of the file, /file 00, and see that they're all data. So really we want to print some of these out. We could go through and manually print each one, or we could just cat /star. So the star, the asterisk is a wildcard, and it's going to print everything. So it's printing out all of them. We can see pretty clearly that there is our flag. Again, just to show you, if we do them manually, we're gonna have to keep running through like that until we get the correct one, which is 7, file 7. So we can reset the terminal, and we can just cat then -file 7. Okay, great. So we can move on to the next level. SSH to the usual address. This time we are doing Bandit 4. Sorry, Bandit 5. Copy the new password, paste it in, and there we go. Okay, so we can see for challenge 5 that the password is going to be stored in here directory. It's going to be human readable. It's going to be 1033 bytes in size, and it's not going to be executable. So if we go back to our terminal and go into the in here directory, we can see that we have quite a few folders. A command that it's not installed on a system. I like the tree command, which I have installed on Kali, which you can use with different options to get more info. They don't have that on here. We could do the recursive ls. I'm going to get a list of all the files that are in each directory. We know what we're looking for. It's a file, I think it was 1033 bytes. Let me just double check. Yeah, 1033 bytes in size. But it's not a very automated approach. We'd have to go through and manually look through all of these files, so we want to try and find a better way to do that. By the way, the ls commands that I'm using there are a lot of options that you can use with it. I'm using LART, so T is sorting by modification time, R is reverse order while sorting, and L is use long list and format, and A is show all files, so don't ignore any entries. Okay, so another command we're going to want to use is find. So in here I should be able to use find, and then just set the size flag to 1033 C, which is C is for bytes. And then we can see maybe here 07 has a file called file2, which is exactly that size. So let's just try and directly cat it. And there we go. So we have our flag for the next level. So I'm going to do our usual process here. I'm going to bandit, we're going to SSH into bandit 6. Let me just copy over the address again. And then we're going to copy and paste the password. Great. Okay. So Bandit 6, if we go back. Okay, so level 6 to 7, quite similar to the previous levels, just trying to get used to some typical Linux commands. So we need to find a password which is owned by user Bandit7, owned by group Bandit6, and it's 33 bytes in size. It could be anywhere on a server, so we don't just have a, if we do ls here, we don't really have anything to go by. So what we're going to do for this command is find, and then a // to search any directory. We want to find something that's owned by user Bandit7 and group Bandit6, and the size is 33 bytes. Sorry, there's quite a bit of lag with this server. Okay, so permission denied for a lot of stuff there, but we can see that we have a bandit7.password file. That's where it's located. We could fine-tune this to only search things that we have permission to access or that actually exist, in which case the only thing that would have showed up would be this file. But I'm not going to do that for this challenge. I'll leave you to work it out. So let's cat the new password and move on to the Bandit7 user. So SSH Bandit7 at and then we move to level 7. Okay, so level 7 it's told us that there's a password. It's stored in a file called data.txt next to the word millionth. Suggested some new commands. Now we can see sort, unique, strings, base64. Quite a few new commands. Not going to really need to use them all anyway. Let's have a look to see what files we've got. We have data.text. You can see that it is full of different potential passwords. So for this we're just going to use the grep command. So we'll grep millionth out of data.txt, and there we go. We have our new password. I'll not copy that just yet because we want to SSH into the new user. Bandit 8 at and there we go, we're on the Bandit 8 user, so we can go back, have a look at level 8 to 9. Okay, level 8 to 9. So the password again is stored in a data.txt file, and it's the only line of text that occurs only once. So there's a lot of ways you're going to be able to do this. If we see here, we have our data.txt. The method I'm going to use is we're going to cat data.txt, and we're going to pipe that through to sort, and then unique-u. And there we go, we have our password. I don't know why I keep copying that before copying the SSH address, but we're going to go to bandit9 at, going to put in our password, and there we go. So on to level 9 to 10. Okay, so level 9 to 10 this time is asking us to find the password in data.txt, which is one of the few human readable strings beginning with several equals characters. So because if we use cat as we have been in the past, you see it's not very readable. It let us know that there was only a few human readable strings. Now it just so happens to be sitting there anyway as soon as you cat out the result, which we could just use. But just to show you, if that wasn't the case, if the challenge had maybe been designed a little better, what we would do. So you can run strings on files that have non-readable data in like that, and strings will give us a list of all strings, I think greater than that are equal to or greater than 4 characters. We could then look for for strings which are greater than, say, 10 characters, because we know the password will be, and we get the password there. But again, if the challenge had been designed a little differently, then there could be hundreds or thousands of strings that are meaningful strings but are greater than 10, in which case we would maybe want to run strings on data.txt and grep out any strings that have equals in them. In doing so, we find a few strings. There's our password, but any of those options for this particular challenge will work fine. So we'll now SSH into Bandit 10. And we go to level 10 to 11. This time around we have the password stored in data.txt, which contains base64 encoded data. So we can, if we cat out data just to see what it looks like, we can see based on the two equal signs at the end of this is a base64 encoded string. There are plenty of tools online to base64 decode it, or we can use base64 as an actual command here. So base64-d, and there we go. So -e will encode, -d will decode, and there we have our new password. So let's SSH into Bandit 11. Forgot to copy and paste the string again. And yes, let's get the password. Okay, and then we move on to level 11 to 12. So for challenge 11 to 12, the password stored in data.txt contains uppercase and lowercase letters and has been rotated by 13 positions. So this is a standard Caesar cipher, which there are many tools online. In fact, there are some nice websites where you can put in a string and it will try and rotate by 26 different positions, and then you can just have a look to see which one is clearly the password, because it's, or the flag, because it's not always going to be rotated by 13. 13 is pretty common because there are 26 letters in the alphabet. So I'm going to show a couple of methods for doing this. First of all, we'll cat out data.txt. This is the string that we are looking to rotate by 13 positions. So we could use Python in the command line. We can use a -c argument for that, and then we'll want two single quotes, or you can do it in reverse with two double quotes, but I'm going to do two single quotes, and then I'm going to paste in the string that we want to rotate, and then .decode, and then just rot 13. We could also have done this for the previous challenge with base64, or if we had a value that was in hex or something like that. All of them will work fine. Oh, sorry, missed one thing there. We want to print that, so we don't just want Python to run that command, we want to print it to the console. And there we go, there's the password. Probably a more popular way to do this for Linux users is the tr command, which is for translate. So we can just echo the string and pipe it into tr, and then we can shift the alphabet. So we want to shift capital A to capital Z and lowercase a to lowercase z. By 13 positions. So we want to do we want to change that from capital N to capital Z, capital A to capital M, lowercase n to lowercase z and lowercase a to lowercase m. So what we're saying here is shift all capital A to Z to N to Z, all, well, capital A to Z, we're going to be shifting N to Z to A to M, and then doing the same with the lowercase values. To be honest, I find it, if you know it's going to be ROT13, see Python doesn't have like a ROT15, ROT16, for example. ROT13 is pretty common, so it has that option. But if this was going to be like ROT7 or ROT8 or something like that, then you might want to use TR command instead. There are going to be other methods. These are two, but both will get you the password. To be honest, I would probably just use the online tool, which would test all the possible values, but it's really up to personal preference. Okay, so we can now SSH into the new user, which will be Bandit 12. Take a copy of that password, paste it in, and move on to level 12 to 13. Okay, so for level 12 to 13, the password is stored in data.txt. It's a hex dump of a file that has been repeatedly compressed, suggesting that for this level it may be useful to create a directory under the temp folder, which you can work using. Yeah, okay, so we'll have a look at how to do this. So we have data.txt. Okay. And it's suggesting that we should make a new directory in temp and call it CryptoCat, and then we will copy data.txt to temp CryptoCat data.txt, and we'll cd into temp CryptoCat, and we can see we have our data.txt file. Let's clear some of this mess from our screen. Okay, so as we saw there, whenever we printed that out, it's not a it was a hex dump, so we need to turn it back into a binary. We can do that using the xxd command. We use xxd-r data.txt into, I'm just going to call it data. Now we should have two files. If we have a look at the file data, we can see it's gzip compressed data. So we need to turn it into a gzip file. So we'll move data into data.gz, and then we want to decompress that, so we can use gzip -d for decompress and data.gz. Have a look, see what files we have now. Okay, file, I'm assuming it's overwritten. Yeah, okay, so it overwrote the data file there, because so that's fine. We're back to the data file. It's now bzip2 compressed, so we just need to use the same, just need to use a different decompression tool. So bzip2-d, and okay, no, sorry, we'll need to move data first. Move data to data.bz2, and then we'll want to use bzip2-d. There we go. Let's have a look what we've got now. We have gzip compressed data, so same process again. We'll move data to data.gz. We'll use gzip-d, and oops. Okay, file data, we now have a tar file, so another compressed file. We will want to, we don't actually need to copy this over, we'll just do tar dash xvf. Okay, maybe we should copy that over, apologies. So we'll move data to data.tar, and we will use tar dash xvf data.tar. Now we have data.bin. So, well, we don't need to run a file on that, we know it's a binary file. Oh well. Okay, no, it's actually another tar file. Okay, we should be able to. I'm going to try just without moving that to a .tar file. Let's just try xvf data 5. Yeah, okay, that gave us data 6.bin. So data 6 is a bzip file. Let's move data 6 .bin to data 6.bz, and then bzip2-d data 6. We now have data 6, so file data 6. Apologies for the lag on this. It's again tar dash xvf and data 6. We now have data 8.bin. Let's have a look what type of file it is. It's gzip. Let's move data 8 to data 8.gz. Cannot. Okay, sorry. Data 8.bin, and then gzip-d data 8-gz. Yeah, they've really they've compressed that a lot of times. Okay, now we have data.txt. That's a good sign. Autocomplete doesn't work too well when you keep naming everything data. Okay. Okay. Oh, that didn't print out data.txt. Let me see, was that data 8? Data 8. Oh, ASCII text. Okay, so we'll just cat data 8. And there we go, the password finally. It was quite a long challenge, just requiring a lot of manual decompression. So we can now move on to Bandit 13. We'll use our new password, clear everything from the screen, and let's have a look, see what the new challenge is. Okay, so the password for the next level is stored in etc bandit pass bandit 14. Can be only be read by bandit 14. So we don't get a password, but we get an SSH key. Note localhost is a host name that refers to the machine you're working on. Okay, so we'll go back to our terminal. We can see we have the SSH key. Looks a little bit like that. What we can do here is SSH, use -i so that we're not to specify that we don't need a password, and we will specify the key instead. and we want to go to Bandit 14, but they said that we should do localhost for this, so yes, okay, there we go. We're now in Bandit 14, although we also need to get the password, which was in Bandit Pass, Bandit 14. And there we go, we have the password. So let's jump back to let's go to level 14. The password for the next level can be retrieved by submitting the password for the current level to port 30,000 on localhost. Okay, so we have the current password. Let's go back. For this, we'll want to send the password to localhost port 30000. We can do that using netcat. So let's echo the current password. We'll pipe that through to netcat on localhost. There we go. Okay, succeeded. Correct. Here's our new password, and let's save the password, exit out of that, and SSH to Bandit 15. Sorry, missed the SSH again. Let's copy our password over. Denied. Okay. Two seconds. Okay. Oh, okay. I don't know. I definitely had the password there. I don't know. I mustn't have copied properly. So that's great. We're into Bandit 15, and let's have a look at level 15 to 16. So level 15 to 16, similar to what we did before there with the netcat, sending it to send the password to localhost. Difference being, we can see this is using SSL encryption. So if you read the note and some of the helpful reading material here, you'll find that we can use the OpenSSL client. So let's echo our previous password. Let me make sure I have a note of it. Yeah, okay. Let's echo this password. We'll pipe it into, rather than just piping it into netcat, this time we'll pipe it into OpenSSL. S client. We can use the quiet option. We want to connect to localhost on port 30001. Great. Okay, so we've got the next password. So to make a copy of that, we should be able to SSH into Bandit 16 at bandit.labs. Yes. And our new password. There we go, we're into Bandit 16. Okay, so for this level we're being told that we can submit the password of the current level to a port on localhost in the range of 31,000 to 32,000. So we need to find out which has server listed on them and which speak SSL and which don't. There's only one that will give the credentials, the others will simply send back whatever you send it. So if we go in and have a look, Nmap, some of the Nmap help, you get a lot of different options that can be used. This is a very common tool used in pen testing, CTF, hacking, whatever you want to call it. And depending on what you're looking to do, there'll be a lot of different tags. -pn is a pretty common tag. If I was running Nmap in a CTF, would normally kind of run something like -pn -a, which is like an aggressive scan, enable, which you can see here, enable OS detection, version detection, script scanning, and traceroute. Put in the address range that you wanted to scan, in this case localhost. You can scan all ports or just define the range, so we could define the range as port 31,000 to 32,000. You can also use, if you're looking to do a UDP scan, it is SU, but that's quite slow. Unless, depending on how deep you need to go on the CTF, will really depend. Also, what's nice is the OX command, where you could then export this to like scan.xml. So later on, if you start looking at things like Metasploit, then it means you can just import the scan and it'll have all the addresses, services, port numbers and stuff like that already in, so you don't need to keep going and flicking back, copying and pasting or typing things in manually. Makes things a lot easier. We don't need to do that for this, because all we're really looking to do at the moment is find out some of the ports. So we'll take some of these options out. And just to mention also, there are some other useful commands here. You might use some of the scripts can be good for finding specific vulnerabilities. Sorry, this is running very slowly, even just to scroll. -SS for like a stealth scan. -SV for looking for specific services. -IR for just choosing random targets. But yeah, plenty of options to choose from. I'm just going to try and run Nmap localhost. We can see here we have 5 open ports. Services on them are unknown. Just out of interest, if I was to go back and try the flags that we discussed previously, to just assume the host is online because we know it is, and -A to enable OS detection, version detection, script scanning and traceroute. You can see it's taking quite a bit longer. Not really too necessary, but just want to show you what kind of output we'd expect to see from doing that. Okay, so that one took a little bit longer. I'll pause the video there so we can see that the first one was 0.08 seconds. This was 41.37 seconds, so quite a bit difference. But what we can now see is that a couple of the services are running just echo. So if we flick back, you can see here that only one server will give the next credentials, the others will simply send back whatever you send to it. So if the service running is echo, then it's going to be of no interest to us. So these are the services that we're going to want to try on these ports. So we will try to echo, let's get that password, we'll echo the password, we will pipe it through to netcat, -v on localhost, First we'll try 31518, and we got an error. So what was the next one? 31790, and we're still getting an error. Okay. Alright, let's try some of the ones that were just echoing. 31046 succeeded, but it just returned the password that we already had. So 31691, just echoing the same password. So it must be 31960. No, just echoing the same password. Okay, so if we flick back to this page, find out which ports have a server listed on them, which speak SSL and which don't. Okay, yeah, so apologies for the mistake there. I was correct in saying that the services running echo are obviously just echoing back the same response. So it was the other services that we wanted to use, but we want to use the Open SSL because it specified that we should be looking for an SSL service. So we'll just run what we were running before. Last time we had to connect with SSL, so what were the port numbers? 31518. Returned the same password, so 31790, and there we go, we have got ourselves an SSH key. So only one server will give you the next credentials. Let's have a look. We go to 17 to 18. Okay, so we're going to need to connect here using the SSH key. Which again we did before, but this isn't an actual file, so we need to make a new directory in let's say temp key and cd to temp key we will take a copy of this key and we'll echo okay, not the best option. Let's try a lot of lag to temp key and ssh key dot private. Just cat that out, make sure it's all looking fine. Yeah, okay. Great. So it all looks good. Now I just need to do the SSH connections we did before. So we SSH, specify I to say we don't want a password. We will use the SSH private key, and we want to go to Bandit 17 at localhost. Yes, we sure want to connect. Add permissions. Okay. Okay, I don't see any problems with the key. I don't see why that's not working out for us. Okay, so just notice there that permissions are too open. It was required that your private keys are not accessible by others. Bad permissions, ignore key. Let's have a look at the permissions. Okay. Okay, I'm going to try and run the same command again. No. Okay, let's us chmod 400 the SSH key. Okay, cool. You'll see here that the permissions have changed so that they're not accessible by others. So let's try again. Perfect. Okay, so we're into Bandit 17. So you'll see, even myself, it's been probably a year since I did a lot of these challenges. Some of them I remember pretty clearly, some of them are easy enough, but you always get stuck on a couple. But anyway, let's move on to level 18 to 19. My apologies, I just realised that it's we're actually still on level 17 to 18, so we've just got into user 17, and we have been told passwords.old and passwords.new exist in this directory. The only line that has changed between passwords.old and passwords.new is our password. So if we were to try and cat passwords.old, you can see there's a lot of passwords. It's going to take a long time to manually search through and see what's changed between the two files. So we can just run diff on passwords.new and passwords.old, and we can see that there's the only change. Now I'm going to make a note of, I'm not actually too sure which one of these two is the password. I'm going to make a note of both, just in case. I'm not too sure, was it saying that the old is the only line that's changed between the two passwords? Okay, so I think it's the second one, but keep a note of both anyway. If you've solved this level and see bye bye when logging into Bandit 18, this is related to the next level, Bandit 19. Okay, so if we SSH to Bandit 18 at, I'll put in our yes. Okay, let's try the first one. Bye bye. Okay, so connection closed. So it did log us in. Just verify that. Welcome. Yeah, it logged us in okay. We're getting bye bye. So this is obviously related to the next level, level 18 to 19. Okay, so level 18 to 19, we can see the password for the next level stored in the README in the home directory. Unfortunately, somebody has modified the bash RC to log you out when you log in with SSH. So what we can do here is try to force sudo tty allocation using the -t flag. So I'm just going to run the same thing again pretty much, but we're going to use -t and put bin sh at the end. The password, I need to put the password in again, And there we go, we've just got into a shell. We can now have a look, see what we've got. There's cat readme. Haha, can't use autocomplete on this. Okay, but we've got the password for the next level. So that's good. Let's try and exit and SSH into Bandit 19 with the new password. There we go, we're in Bandit 19. Okay, so let's go and see what the next challenge involves. To gain access to the next level, you should use the set UID binary in the home directory. Execute it without arguments to find out how to use it. The password for the next level can be found in the usual place, which is etc bandit pass, after you have used the binary. So let's try and run it and see what it does. Okay, run the command as another user. So, for example, ID. So, who am I? I'm Bandit 19. So we're going to want to run this Bandit 20-do with the ID of another user. So let's try Bandit 20, and then let's try and cat etc bandit pass and bandit 20. Okay. That's Bandit 19. Okay. Let's try again. No. Okay. Okay. Right. I think this. No. Okay. So leave the pipe out. You don't need to specify Bandit 20. So this is already by default. Let's see if we can even dash bandit dash h. So it gave us a password there. Essentially, it was already just setting it to user 20. We didn't need to specify which user to test it as. That's cool. So we've got the next password. What I'm going to do is exit out of this. The reason being, I already have this saved. That means I can just go bandit 20. Yes. Put in the new password we got, which I just typed incorrectly. There we go. Okay, let's clear that and go and find out what the next challenge involves. Okay, so this challenge says there's a set UID binary in a home directory. It does the following: it makes a connection to a local host on a port you specify. It then reads a line of text from the connection and compares it to the password in a previous level. If it's correct, it'll give you the one for the next level. So if we have a look here, we have SU connect. We try and run that. Okay, so it wants SU connect and a port number. So we need to create a netcat listener. So essentially what we're going to be saying is echo this command, or echo this password whenever anybody connects to netcat listener on port. We can choose a port here. Let me just say 1700. See what happens. Okay, so nothing is happening there. I'm going to exit that. Just added in an AND at the end of that, just to get me out of. So it is running that netcat listener on port 1700. So if I run su connect 1700, there we go. So it's read this password and it's sent us a new password. Awesome. So let's just exit. Let's go and jump into Bandit 21 with the new password. Great. Okay, don't see anything sitting in the home directory, so let's go and see what this challenge is about. So we're now on 21 to 22. Okay, so level 21 to 22 is about cron. So program is running automatically at regular intervals from cron, time-based job scheduler. Have a look in here for the configuration and see what's been executed. So let's see what we have. We can see cron job bandit 22. That's where we're trying to get into, so be a good start. And what is happening then? Okay, so this script is running, user bin cron job bandit 22. So what is the script doing? We cut that out, and the script is changing the privileges of this temp directory, and then it's cutting the bandit pass into that temp directory. So let's have a look in. Let's have a look in that temp directory. Oh, it's not a directory. Okay, so let's try and cat that. And there we go. So it was just catting that to a text file. That was the text file that it was catting it to. So let's exit. Let's jump into Bandit 22 with that new password. Don't have anything sitting in the home directory again, so let's go to level 22. Okay, so for level 22 we have another cron job. So let's go and have a look and see what command is being executed. So let's cat out cron job bandit 23, and then this is the script which is being run, a shell script. So again, let's cat this out. And what's actually happening? So the my name variable is being set to who am I, which for me who am I, which for me would be bandit 22. And what it's doing, it's setting my target to echo I am user my name, which would be bandit 22 if I was running it, but for this script will be bandit 23. It's then passing it to MD5 sum. I'm doing a cut operation. It then copies the password file to temp my target. So this my target here is equal to this. So essentially we need to find out what file name this would create. Now if I were to copy that directly, then change it to bandit 22, this would be the value that it would be printing out, but that's not the value that we want. We want it for bandit 23. So we'll change it to 23, cut it out, copy this, and then we'll cat temp, and there we go, we have our password. So we can exit, we can jump in now as bandit 23. Okay, so nothing's sitting in here. Maybe we've got another cron job for the next level. Let's find out. Level 23, yes. So in this one, a program is running automatically at regular intervals. Go and have a look to see what's being executed. Note, this level requires you to first create your own shell script. Okay. And it's removed once executed, so you may want to keep a copy around. Cool, alright, so let's go and take a look at it. Okay, so again, we want to cd into the cron folder, cat out the cron job 24, oops, and then we want to cat out the shell script and have a look, see what's going on. So again, this is executed as the user Bandit 24, and essentially it's going to cd into this directory and it's going to execute and then delete all the scripts. So what we want to do is write a script which is going to execute, bearing in mind it will be deleted straight away, but if we can just get it to write out the password somewhere, then that should be no problem. So let's create a new directory. Sorry, what am I doing? Create a new directory. Let's say temp CryptoCats and cd into it. CryptoCats, and we want to create a new shell script. So let's just say new -sh, set up our shebang, bin/bash, oops, okay, and yeah, all we want to do then is cat the password, so it's in etc bandit pass, and we want bandit 24. Let's cat that into the new directory we just created, so temp CryptoCats pass, and that should do us. We'll save that. We want to change the permission of the shell script. We also want to change the permission of the folder that we're in, just so that it can write to it, okay? And then we can move this shell script, well, we'll copy it just in case it doesn't work and we want to make some changes. Copy the shell script into var spool bandit 24. So I think that's executed like every minute. So it'll be executed, it'll delete the script. In fact, what we could do is cat bandit 24 new. By the time I do it, it's probably gone. Yeah, gone. Okay, so yeah, now we have pass. Let's just cat the password. Got the password for bandit 24. Awesome. So exit. We'll go and just jump in with bandit 24. Alright, let's clear up some of the mess on the screen and jump over to our next level. So in this one, Damon is listening on port 30,002, and we'll give you the password for bandit 25 if the given password for 24 is a secret numeric 4-digit pin code. There is no way to retrieve this pin code except by going through all 10,000 combinations, called brute forcing. Cool. Okay, so I'm going to use a Python script for this challenge. It's typically what I would do on CTF challenges like this, and it's a great language for anything security and network related. It's not an ideal language for this challenge, and I'll explain why shortly, although it does work for me. I just slightly modified similar scripts that I've used in the past. It's quite a small script. You could modify it to work for all possible solutions, but well, I'll explain more in a moment. So I've created a temp directory here, temp crypto, and the first thing you want to do with any challenge like this is try and get an idea what the input and the output is going to look like. So if we do netcat localhost on 30002, it's asking for the password of the current user and a 4-digit pin separated by a space. So if I enter in the current password and 0000, hit enter, wrong, try another pin code, and that's fine. So in a lot of challenges, what you might want to be doing is adding like regex to check the result. This is a very basic challenge, but a lot of challenges you'll be looking for a specific words or specific regex in the response. So I have plenty of scripts to do that. Once you've got a script that's there, it's very easy to just go in and modify them based on whatever the CTF challenge is looking for. I'll show you the script that I have written for this. I'll run it and I'll explain why it's not ideal. Okay, so the script that I have, got a Python script. It's just creating a socket. It's going to try and connect to localhost on that port. If it fails, it'll give you the error and it'll exit. And then we have a counter starting at 0, which is basically going to run through all 10,000 combinations, and it will check the reply. If there's no reply, then it's going to exit the script, and then it will send the current answer. So it'll send the current count, or send the current password along with the current count, and it'll increment count. It'll keep doing that until it gets to the correct reply. So this will work. I'll show you this running and explain why it's not ideal afterwards. So let's call this brute.py, paste that in, and run it. Oh, you did not supply enough data. Okay, sorry, I missed the space in. If you're going to be working on a script, by the way, work on it on your local machine, on your VM or something. Do not work on it on the over-the-wire server, because they have a terrible connection. Anyway, run that again. And boom, okay, so the correct answer was 2477, and we now have the password for Bandit 25. So why was this not a great solution? Well, that turned out to be the correct pin, but if the pin had been anywhere less than 1,000, we would have been sending a 3-digit number instead of a 4-digit number. So instead of sending 0000, initially it would just send 0, because that's the way a count works in something like Python. There are scripts online. I'll quickly flick over to a script here. There's a bash script somebody's done for the same level, which is far more efficient. So it's maybe worth looking into something like that or you could modify that Python solution. You certainly could set that up to, if it's less than 1,000, to add the extra digits, but it's going to be quite a lot more coding for little functionality, which isn't completely necessary. But it's fine. We got the password. I couldn't really be bothered going and doing a bash script or modifying that. We've got a flag. Let's move on to the next challenge. So if we take that password and exit, we can try, but unfortunately typing anything into this system is unbelievably slow. Okay. Oops. So Bandit 25. Yeah, I don't know, I think they must be running like a 56k dial-up modem to host all their challenges on. It certainly seems that way.
while we're waiting forever for that to load, let's go and have a look at what challenge 25 is. Okay, so logging into 26 from 25 should be fairly easy. The shell for the user is not bin bash but something else. Find out what it is, how it works, and how to break it. Okay, interesting. If we can ever get in there, then we certainly will. Action closed. There we go. Okay. Great. Okay, so we're into Bandit 25. Let's clear all this stuff from our screen. Have a look to see. Okay, we've got an SSH key. Great. Okay. So this is just going to be our usual SSH -I /bandit 26 SSH key, and then we just need to copy in our address. So bandit 26 at, there we go, yes. Okay, yeah, so it's pretty easy to get in there. Okay, no, sorry, it wasn't. Okay, so it let us in. This was like the challenge that we saw earlier. So let's see how we can get around this. Okay, yeah, so like the earlier challenge, where it lets us log in but kicks us straight out, we need to find out what the shell is here. So it gave us a pretty clear hint that the shell was something different. So we'll type in here cat/etc/password passwd. It's pretty unbelievable, the state of the connection here. I'm sure anybody doing these challenges and watching will have experienced some equally frustrating problems. Let's go back up, get the password for Bandit 25. Let's run cat etc password and grep Bandit 26. So it's actually not a shell. It is show text. Instead of user/bin/sh, we have user/bin/show text. If we want to find out a bit more, we can cat that out and see what it actually does. So actually it runs bin and shell and then does more and more on text.txt and exit 0. So what we need to do here is try to minimize our shell and run the same command that we ran earlier, SSH-I bandit SSH key, and then bandit 26, do at localhost, since we are already in on the same server, and then cat text dot. Sorry, do bear with me, it takes a long time to do anything on this. Okay, so let's try that again, but with another flag. There we go. Okay, more. So what we can do now is press V to enter Vim. And we can see this, Bandit 26. Great. Now let's do E. Colon E / etc / bandit pass / bandit 26. Okay, must have been a typing mistake in there. Probably just due to the extreme lag. Bandit pass, bandit 26, and that has let us edit the bandit 26 password file, which is exactly what we wanted to do. That's fine, connection closed, it's good, we don't want to be in there anyway. What we want to do now is just SSH into bandit 27. Okay, sorry, no, and okay, Bandit 27, let's go and have a look to see what it actually has here. Bandit 26, 27. Oh, okay, it doesn't exist, that's why we can't get onto that. Okay, so that was the last challenge then. Yeah, okay, so I hope you've enjoyed these walkthroughs. I know some of them have been quite slow, partly due to myself, partly due to the incredibly slow server that these challenges are run on. But hope you've enjoyed them. Up next, I think, will be the NATAs, which are web challenges. Any questions, comments? Please leave them below, and I'll try to get back to you.